we're back. Now that I finished chapter 13, I'm going to go over some of the problems you had on the quizzes. Quiz 5 and 6, the first one, y equals 1/3 the log of x fourth plus 3 to the cubed. Find dy dx. This is a very complex problem because the argument itself is a chain rule. It's a chain rule within a chain rule. I haven't seen too many of these on the final. I'm going to send you an email with the complete solution. I don't think this will be on the final, but I'll send it to you anyway. Quiz 5, 6, number 2. A lot of people got wrong. Y was equal 1 plus e to the 2x over e to the 3x. Find dy dx. First thing you want to do is simplify it by dividing each term in the numerator by e to the 3x. I got 1 over e to the 3x plus e to the 2x over e to the 3x. Bring this up to the top. E to the minus 3x plus e to the minus 3x plus e to the 2x is e to the minus x. Now I take the derivative. That'll be the derivative with respect to x of e to the minus 3x. Derivative with respect to x of e to the minus x. This is the exponential chain rule. This is minus 3 to the minus 3x minus 1 minus x, and that is the answer. This is the answer. And if you want to see how I did it, this is the exponential chain rule. If I have y equals a e to the u, then dy dx is going to be a e to the minus u du dx. In this case, a was equal to 1, and u was equal to minus 3x. This is a to the u. Sorry about that. A to the u, make it general. U is minus 3x, and du dx, and du dx equals minus 3. Substituting in the chain rule for this one, make the derivative is going to be a is 1, e to the minus 3x, just bring back the exponent, and minus 3 is the derivative. That is simply minus 3 e to the minus 3x. That's the first term here. Do the same thing with the second term, where a is equal to 1, u is equal to minus x, and du dx is minus 1. All right, so that's the answer here. I don't know, some people messed it up because it was a lot easier. They tried to do a quotient rule, and that made it a little bit harder. Always try to simplify your problem first before you start to take the derivative. Notice I'm taking derivatives. I'm starting with the function and taking a derivative. There are no constants. It's not integration. Okay, let's do the next one. The same quiz. Unfortunately, seems that people have problems with straight lines still. So quiz 5 and 6, number 3. Okay, and what I was given, y equals x e to the minus x. And I'm given the points 1 and I don't know. That's x and y. So I want to find the equation of the line tangent to this function at the point 1 and whatever the y is. So the first thing I want to do is find the y. Go back to the equation and just substitute in 1. And that's going to be equal to 0.368. Okay, 1 times e to the minus 1. E to the minus 1 is 0.368. So now the point we want to find the straight line is on 1 and 0.368. Next thing is to find the slope. In that case, you have to find dy dx. And that is going to be a product rule. X times the derivative, e to the minus x, plus e to the minus x, the derivative of x. So y prime of x becomes, it's going to be x times the derivative of x. It's going to be minus x e to the minus x, and this is going to be just e to the minus x. I can factor out the e to the minus x if I want, leaving me with 1 minus x. And I want to find the derivative at x equal 1. Well, that's e to the minus 1. 1 minus 1, that's 0. So I have a 0 slope. This might have thrown somebody off, but this actually makes your whole problem a lot easier, because you want to substitute this into the point slope form. I'm sorry, this pen is met the end.
It's visible in the video. I mean,
yeah, but I still like it.
I know it's not great, but
yeah, not great. Okay, so we have y minus y0 equals the slope x minus x0. So y minus y0 is 0.368 equals 0 times x minus 1. Well, that's 0. So y comes into 0.368. So y is simply a horizontal line with a slope of 0. That's it. No fuss, no muss. I think a lot of you got confused because it came out to be 0 and they thought you were wrong. But don't look a gift horse in the mouth. It was supposed to be a gift, making it a lot easier. Remember, always find the other variable first. So you have your y0 and your x0. Okay, now let's go on to quiz 7 and 8, which has a lot more problems than quiz 5 and 6. I'll leave this on the board. We're going to do quiz 7 and 8, and I'll use that as a header. And the first thing I want to do is the implicit differentiation. That's a little bit shorter. Okay, so I'm going to do number 2, which wanted the elasticity of demand. Well, we have our equation here, minus P over Q dq dP. Now, I don't know why, but dq dP is not the elasticity of demand. I had people solve for dq dP and use that as the elasticity of demand. This is the elasticity, eta or n. In order to get elasticity, you have to do minus P over Q times dq dP. dq dP does not give you the elasticity of demand. I had a whole number of people just give that to me as the elasticity. Now, I never taught it that way. I don't know where you got that idea, but that is a derivative. The elasticity function is defined as eta or n. If you don't like Greek letters, I know it's Greek to me. So we have to find, we need P, Q, and dq dP. So what are we given? In this problem, we are given two things. We're given the function P plus 5 Q, P squared Q equals 1, 0, 1, 0. We're also given that the constant P equals 10. So I have one of them. Our first step should always be, if they don't give you both constants, find the other constant. Find the other constant by substituting in the original problem. P is 10. 510 squared. Q I don't know. I have 10 plus 5 times 100. Q equals 1010. Subtract 10 from both sides. 500Q equals 1000. And Q equals 2. So now I have, if I want to do Q and P, it's going to be 2 and 10. So I have two parts of this. Now I need dq dp. So find. For this I need implicit differentiation. Go to equation 1 and just follow what I do. I'm taking the derivative. Basically, we're talking about the derivative of a function in Q with respect to P. Okay? That's what I want. So let's look at the first term. dP has to be over dP. Let's look at the second term. The second term is a product rule, where I have U equals 5P squared and V equals Q. I'm going to take the first times derivative with respect to P of Q plus the second, which is Q times the derivative with respect to P of 5P squared. And the other side, I take the derivative with respect to P of 1010. I know that that equals 0 because that's a constant. Now let's look at this. This is a function in P, and I'm taking it with respect to P. What we're used to seeing is taking d of the 4 of x with respect to x. I can do that. So this is 1p, so this is just 1. Now let's look at the second one. 5p squared. This is a function in Q with respect to p. I cannot do that. There's no p in here. It's silent like the p in swimming. So anyway, dq dp I cannot do. So I do a dummy here. I say I can take dq with respect to dq. But now I've unbalanced this term. In order to balance it, I multiply times dq dp. So really, I haven't done anything because the dq's and a d and a denominator cancel. But that's what I want to find. So implicitly, I put the dq dp there. Now look at this one. Q, you have 5p squared with respect to p. I can do that. 2p's times 10p. So I got 1 plus, the derivative of q with respect to q is 1. Plus 10qp equals 0. My whole goal is to find dq dp. I'm going to solve for it as a variable. I'm going to bring these over to the other side. So I get 5p squared dq dp equals minus 1 minus 10qp. Now I want to isolate dq dp, so I divide both sides by 5p squared. All right?
You're coming up to 15 minutes.
It's all right. So we'll put the rest up here. I can go over a little bit. I want to finish this problem.
Yeah.
So I got dq dp equals minus 1 minus 10qp over 5p squared. In order to find dq dp, I have to substitute in here for q and p. Minus 1 minus 10 2 times 10 over 5 times 10 squared. Okay. So what do I get here? Trying to figure this out here. I'm going to get equals minus 0.402. Now I have everything that I need to solve for my elasticity index. So n is going to be equal to minus p, which is 10, over 2 times minus 0.402. Minus times a minus is a plus. What we get here is 0.201. Oh no, I didn't get that. I'm sorry. It's 2.01, I believe. No, yes it is.
Yeah.
Yes it is, because that was a minus. Okay, let's.
So it's 5 times 0.4.
It's 2.01, which is greater than 1. So this is elastic. And that's all you needed. Okay, we'll be back in a few minutes.